Today, we are going on a journey into one of the most incredible pieces of biological engineering inside all of us, the vascular network that fuels our brain. It is an amazing story of pipelines, highways, and a safety net that is just genius. So let's start with a fact that just blows my mind every time I hear it. Your brain, right? It's only about 2% of your body weight, but it is an absolute energy hog. It demands a full 20% of all the oxygen you breathe. So how on earth does it pull that off? How does our body keep up with that insane demand? Well, the secret isn't one single massive fire hose of blood. Instead, it's two completely separate, really sophisticated arterial systems. They start in different places, they take different routes up to the head, but they work together in perfect harmony with one single mission: keeping your brain constantly bathed in oxygen-rich blood. So, here's the game plan for our journey. First, we're going to meet these two main pipelines. Then, we'll trace the blood all the way from the very beginning, at the heart. We'll follow the unique path of each system, the vertebrobasilar and the internal carotid, and then, for the grand finale, we'll see how they all connect in one of the most elegant structures in the entire human body. Okay, first things first. Let's get properly introduced to the two main characters in this story, the two big pipeline systems that are, right now, fueling your every thought. And as you'll see, they have very different jobs. I love this comparison because it really breaks it down. On the left, you've got the posterior system, also known as the vertebral basilar. Think of this as the deep infrastructure. It supplies the really old, fundamental parts of the brainstem, the cerebellum, the stuff that keeps you alive. On the right, you have the anterior system, the internal carotid. This is the main highway, the superhighway that delivers the bulk of the fuel to the cerebrum, where all your complex thinking and personality lives. But, to really understand these two systems, we have to go back to where it all begins. So let's trace this flow right from the source, the heart. So, it all starts here, at the aortic arch. Fresh, oxygenated blood gets blasted out of the heart and hits this huge, curved artery. And right from the top of this arch, 3 massive arteries branch off and head north. These are the launch pads. These 3 vessels are going to give rise to the 4 main arteries, 2 on each side, that will make that final critical journey up into the brain. All right, let's follow our first pipeline. We're going to track that deep infrastructure route we talked about, the vertebrobasilar system. And this one takes a really cool, kind of sneaky, and very protected path to get where it's going. So the journey begins with these 2 vertebral arteries. And check out what they do. Instead of just running up the soft tissues of the neck, they actually thread themselves up through these little bony tunnels in your cervical vertebrae. It's like running a crucial pipeline inside a concrete casing. It gives them an amazing amount of protection from injury. So after this long protected journey up the spine, these 2 parallel arteries arrive at the base of the skull. And right there, they do something you don't see very often in the body. They merge. And just like that, 2 become 1. They fuse together to form a single, much larger basilar artery. This powerful vessel then runs right up the front of the brainstem, which of course is why we call this the vertebrobasilar system. Pretty logical, right? Now, as this system travels up, it sends off all these critical branches to the spinal cord, the cerebellum, all those vital structures. But the journey ends when it splits one last time into its 2 final branches, the posterior cerebral arteries, or PCAs. These guys are super important. They feed the back of your brain, your occipital lobes, where you process vision. Now remember the PCAs. Tuck that away because they are a key piece of our final puzzle. Okay, pipeline number 1, check. Now for the other one, the internal carotid system. If the posterior route was the scenic, protected back road, this is the high-speed, 4-lane interstate highway. So the 2 internal carotid arteries, or ICAs, are the big ones. They're the pulse you can feel in your neck. They shoot straight up and make this really dramatic entrance into the skull through their own dedicated tunnel in the bone, called the carotid canal. And once they're inside the skull, they don't just go straight up. Nope, they have to navigate this really complex, winding, S-shaped path through a busy network of veins called the cavernous sinus. Finally, they pop out right at the base of the brain, ready to unleash their huge supply of blood. And the ICAs also give off some really important branches. For our story, the most critical are its two massive final branches, the anterior and middle cerebral arteries, which supply the vast territories of the front and sides of the brain. But there's also this one other small, almost forgettable branch called the posterior communicating artery. It looks tiny, but trust me, that little guy is one of the heroes of our story. We'll see why in just a moment. So here we are. We've traced both pipelines all the way from the heart, up the neck, and into the skull. We have the branches from the posterior system sitting at the back, and the big branches from the anterior system sitting at the front. Now, for the grand finale, let's see where these two great systems finally meet. But before we build it, we need one key term, anastomosis. It sounds complicated, but all it means is a cross-connection. It's like a bypass road or a detour that connects two different routes. And whenever you see an anastomosis in the body, it's usually a backup system, a safety net. And the one we're about to build is the most important one of all. Okay, let's build this thing from the ground up. We're going to start at the back with our posterior system. Here's the top of the basilar artery, and you can see it splitting into those two posterior cerebral arteries, the PCAs, fanning out toward the back of the brain. All right, now let's bring in the heavy hitters from the front. Here come the two internal carotid arteries. They send those huge middle cerebral arteries way out to the sides, and the two anterior cerebral arteries point toward the very front. And here it is. This is where the magic happens. Remember those tiny little posterior communicating arteries I told you about? Well, this is their moment. They reach backward from the carotid system and connect directly to the posterior cerebral arteries, linking the front system to the back system on both the left side and the right side. We're almost there. We just have one final piece missing to close the loop. A tiny little vessel called the anterior communicating artery forms a bridge between the two anterior cerebral arteries right at the very front. And with that one last connection, boom, we have a complete, perfect arterial ring at the base of the brain. This beautiful structure is the Circle of Willis. I mean, just look at it. It's an incredible piece of anatomical architecture. But it absolutely begs the question, right? Why? Why go through all the trouble of building this intricate, elegant circle? What is the point of all this? And the answer is just so profoundly cool. It's a safety net. It is the ultimate backup plan. Because all these major arteries are connected in a loop, blood has more than one way to get to any given part of the brain. If one of the main arteries supplying the circle gets slowly blocked off, blood from the other arteries can just reroute, go around the circle, and supply that same brain territory from a different direction. It is a masterpiece of redundant design, ensuring that the most important organ in your body is protected from a single point of failure. It is evolution's brilliant solution to keeping the lights on no matter what.